So we are back here to learn how to find value of a determinant of size 3. Now we learned last time how we can find value of determinant of size 3. But what we'll do this time is we'll pick some negative values and see how do we take care that these negative values do not come and torture us, do not come and haunt us. Because for students coming from non-mathematics background, these negatives can be a bit tormenting. So, what was our trick to find value? We take these two columns, leaving the last column. Trick is to leave the last column and take all the columns and rewrite them once again. So here we'll take these columns and leave the last one. Always leave the last one. Let us go ahead and do so. 1, 1 and minus 3. 1, 1 and minus 3. 2, 5 and 1. 2, 5 and 1. Done. So now that I have rewritten my columns, let me go ahead and solve them. First is all leading diagonals. First one, second one and third one. These diagonals are starting from top and coming to bottom. So first we'll take these diagonals and multiply them. 1 multiplied by 5 multiplied by 4. 1 multiplied by 5 multiplied by 4. Then there is a plus sign and we start with next diagonal. 2 multiplied by minus 2 multiplied by minus 3. 2 multiplied by minus 2 multiplied by minus 3. Then we put a sign and we start with the last diagonal, which is minus 1, 1 and 1. So we get a minus 1 multiplied by 1 multiplied by 1. So remember, whenever we are coming across these negative signs, what I am doing is I am hiding these negative signs within a bracket. You never leave these with negative signs open, because then they could cause confusion. If you are comfortable with numbers, you can do it as you wish. But if you are not comfortable with these plus and minus signs, it is better to hide them within brackets for the time being. Then we'll see what we need to do with them. So we are done with leading diagonals. Let us put a minus sign and start with trailing diagonals. This is our first diagonal. What is it? Minus 3, 5 and minus 1. What I said, hide these negative signs in brackets. Minus 3 multiplied by 5 multiplied by minus 1 plus second diagonal. What is it? 1, minus 2 and 1. So 1 multiplied by minus 2 multiplied by 1. As soon as we see a negative sign, we hide it in bracket. Done? And what is our last diagonal? It is 4 multiplied by 1 multiplied by 2. So plus last diagonal, 4 multiplied by 1 multiplied by 2. We didn't remove the diagonal. Just a second. So last diagonal is 4 multiplied by 1 multiplied by 2. Here is our last diagonal. 4 multiplied by 1 multiplied by 2. Let us close the bracket. Now this is simple calculation. Let us see how it goes. 1 multiplied by 5 multiplied by 4. 1 5s are 5, 5 4s are 20. 2 2s are 4, 4 3s are 12. So I get a 12, but because there are two negative signs, I get a plus. Then there is a 1 multiplied by 1 multiplied by 1 with one negative sign. So what I'll get is 1 but with a negative sign. Why this negative sign? Because I'm having only one negative sign in these three. So that is why this negative sign will survive and it will show up in our calculation. This is our first bracket that we have done of leading diagonals. This reduces to this. Next, let us start with our second bracket. This minus sign coming here, and open the bracket. We have opened this bracket. Now let us go ahead. 3 multiplied by 5 multiplied by 15 with two negative signs. So two negative signs tend to cancel each other, and in turn we get a positive. So 3 multiplied by 5 is 15, but with a plus sign, which we need not write. Next, 1 multiplied by 2 multiplied by 1. So we get a 2, but this time I have only one minus sign, so it will survive. It will not cancel out. It will leave me with a minus 2. And last one is 4 multiplied by 1 multiplied by 2. It is a straightforward case of 8. So see, things are getting simplified. Now we can just solve these brackets. 20 plus 12 would give me a 32, minus 1 would give me a 31, minus 15 minus 2 would give me a 13, 13 and 8 would give me a 21. This would make it 31 minus 21, giving me a final answer of 10. So when we solve this determinant D, our value is 10. This determinant can be represented by 10. Thanks for watching.